Hi guys. So today I'm going to be going over a little project that was pretty much inspired from one of my professors here at the University of Washington in Seattle. His name is Dr. Lovelace. Um, this is about 3D distances, and basically the project was about you're given 2 points. So let's say we have some point P, and it could be any numbers basically. And we also have a point Q, which also has three um, numbers in it. It has an X, Y, and a Z for both points. And the idea here is we're going to equate these 2 points. So actually, we also have another point, which is X, Y, Z. This is any point in the plane. And we want to find, let's say this is R. And we want to find the distance from P to R is basically twice the distance of Q to R, right? So let's go through a short example here. So let's say P has the point -2, 5, and 2. Q has the point 6, 3, and -1. Then R is X, Y, Z. And we want to find this distance right here. So if we go through it, well, here we want to use that distance formula, right? And so we want to use the distance formula. We want to get the distance of PR. So that's going to be x plus 2 squared, y minus 5 squared, z minus 2 squared, which is equal to twice the distance of QR. So x minus 6 squared, y minus 3 squared, z plus 1 squared, right? And then we get rid of that square root there. So copy this. This is 4. Because remember, we did this, we squared both sides, so this is now 4. Then we copy this. Right? And then we expand. So this is x squared plus 4, x plus 4, y squared minus 10x plus 25. Then the z part, z squared minus 4z minus or plus 4 actually. And this is equal to 4 times, and then we expand this this thing right there. So this is going to be x squared minus 12x plus 36, y squared minus 6x, 6y. Oh, I just realized I've been putting x here. This is y, and then that's z. Y squared minus 6y plus 9. Then z squared plus 2z plus 1, right? Okay. And then we just multiply the 4 to that side. So we copy this thing here. Right? And then this is equal to 4 of each of these. 48x, 36 times 4. Not good with math, but okay. So I have a calculator. Or y squared minus 24y plus 36. 4z squared plus 8z plus 4. Okay. And then if we continue to solve for that, yeah, we should get somewhere along the lines of putting all of the x and y's in x, y, and z's in one side, and the ones without x, y, and z to the other side. And so I'm going to get this value. You guys can confirm it. Yeah, because this is some long computation, but the idea is just to get the x, y, z in one side and to get all of the numbers to the other side. There we go. So I got all of the x's, all of the y's, and all of the z's in one side. Okay. And then from here, we want to complete the square, right? Because here, if you notice something, there's an xyz here, but this is actually an equation of the sphere. So if we complete the square, let's say we have ax squared plus bx plus c, right? Let's say you have that. I actually have a formula here, which is funny. Yeah, I did get a formula here somewhere. But that's basically a x plus b over 2a. We square that minus b squared 4a plus c. Now to prove that this works, we can, well, solve it, right? So we have x plus b over 2a. We multiply that to each other because it's squared, right? And we have here b squared over 4a plus c. And then from here, we just multiply this thing. So x squared plus bx to a plus bx to a, right? Plus b squared for a squared. Then copy. And then we have this is 2b, right? So this becomes 2bx to a. We cancel out the 2, so we have bx over a. Then we copy again. And basically, we just multiply a. So this is ax squared plus bx plus b squared over 4a minus b squared. Let me just copy here, 4a plus c. And this is basically 0. And so here we have ax squared plus bx plus c, which is the one that we got before here. This thing. So now we know this works. So I'm gonna get rid of this computation right here. So, right. We have each of these. So we want to complete the square of each of them. So let's start with x squared minus 52 over 3x, which is basically x minus 52 over 3 over 2, which is just 52 over 6. Which is, can simplify that. Uh, 26 over 3. Yeah, we square that. We subtract b squared, so this thing squared over 4a. Over 4, or a is 1 in this case. So what is this? 52. So this is 2704 over 9. And we divide that by 4, so we got 2704 over 36. Right? We don't have a c anywhere, so that's just plus 0. 2704 over 36 is 676 over 9. Which I think should be correct. Let me double check. It should be. What was it? Nope, not this one. Yeah, because I did the exact same example here, actually. Yeah, there. So minus 676 over 9. Okay. Yeah, I messed up the formula there, but now I got it. And then we do the same thing basically for the other stuff. So yeah, basically when we do it for all of them, I'll just write the whole thing. Okay. So if we do all of them, we'll get basically this thing right here. So we get this for the x part. We add it to y, this y part. And then we add it again to the z part. Okay. And then from here, we can literally now see this is an equation of the sphere, because we just take these constants to the other side, and now we get an equation of the sphere. So if we do that, we'll get something like this. And then if we just do all of that manipulation there, we get 308 over 9. And then from here, we can say, oh, this is the radius. I'm kidding. This is the center, and this is the radius, or r squared rather. So if we were to find a center and radius of the sphere, we will basically get, so for center, we have 26/3 for our x, 7 over 3 for our y, and -2 for our z. Right? And this makes total sense. For our radius, we basically get square root of 308 over 9. Because this is r squared. So to get r, we just square the thing. And this is what? 308 over 3. If you want to be more specific, but that's the idea. Right? But now what's interesting about this is if we get like the distance between those 2 points, right, from the beginning, and we do it twice of a different point, or a different distance here, twice of a different distance, but they're all referring to some r, right? And what if we make this general? What if we make everything here general? Can we make something general here? Maybe we can find some sort of relationships here, right? Let's say this p, instead of it being -2, 5, and 2, we can make it general, like xp, yp, zp. And then for Q, we can make it something like XQ, YQ, ZQ. R is the same. It's the same X, Y, Z. And we find those distances. And let's say it's not just twice. Maybe it could be some other multiplier. We can denote it as alpha, right? We can denote this as alpha. Well, if we do that, so that's the suggested project. So the idea here is basically, so for our project here, what if we make our multiplier general? So instead of it being 2, it's alpha. And maybe we can ask, is there some sort of formula that given alpha, maybe we can find the radius and the sphere. Radius and center. Right? Seems to be interesting. So we're going to try doing that. Okay. So let's say we have our P, which is XP, YP, ZP. And we also have our Q, XQ, YQ, ZQ. And here we assume they're all constants, right? And then we're doing that distance thing. And we also have our R, which is X, Y, Z. And this is referring to any point. So these are our variables, X, Y, Z. But this X, Y, XP, YP, ZP, XQ, YQ, ZQ, these are constants. So here we're basically looking at the distance of PR, and we equate it to alpha of QR. So how does that look like? Well, again, we just apply that distance formula. So we have X minus XP squared, Y minus YP squared, Z minus ZP squared. And that's alpha of X minus XQ squared, Y minus YQ squared, Z minus ZQ squared. Right? Then we get rid of that square root. So how do we do that? So if you want to get rid of that square root, well, we just put everything to the power of 2, right? So it's going to be, use the same color, X minus XP squared, Y minus YP squared, Z minus ZP squared, and this is alpha squared. And here, we do the same thing, X minus XQ squared, Y minus YQ squared. And Z minus ZQ squared, right? And then, so we're gonna expand, just like the previous one. So how do we expand this? So let's try one case, because I know if I do it for one of them, I just need to do the same thing for the other. So we just change the letter, right? So instead of X, we change it to Y and Z. So it's going to be X squared minus 2X XP plus XP squared. And so knowing that, we basically do that for all of them, right? So actually change this to red. I don't know. I just feel like it. Okay. So yeah, let's do that. So this is X squared minus 2X XP plus xp squared. So that's for one of them. And then we add it to our y. So y squared plus 2y yp plus yp squared. Then we add it to our z. So z squared plus 2z zp plus zp squared. And we equate it to alpha squared. And here we have, well, same idea. X squared minus 2x xq squared, xq plus xq squared plus y squared. Oh, I just realized this subtraction. And then this is y squared minus 2y yq plus yq squared. And then we add the z part. Do z, zq, zq squared. Right? So we've, this whole thing right here is, we basically expanded it. Right? Now, what's next after expanding? Well, we can put the alpha in all of them, right? So we do nothing here. So we copy paste. And then for our alpha, oops, uh-oh. Oops, okay. So my pen's not working. Okay. Nice, my pen's not working. Pen's not working. Wait. Let me stop sharing for a bit. I will restart my OneNote as it's not working again. Yeah, I'm having a bit of technical issues with the OneNote. Sometimes when I switch to the eraser and then I try to switch back to the pen, it doesn't work for some reason. Okay, and I'm back. Okay, so the idea here, what we're doing is we're distributing a. So we have a squared, then we have the x squared minus 2xa squared, or alpha, I keep saying a. Alpha squared, x squared plus alpha squared xq squared. And then here we add alpha squared y squared 2y alpha squared. So here you basically just change everything to y. Alpha squared yq squared. Then again, alpha squared y squared 2y. We already did y. We're doing z now. Z alpha squared zq plus alpha squared. How many times have I said alpha squared? Zq squared. Okay. So that's that. We've distributed alpha in all of the terms. Let me count. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So we've done that. Now, after expanding, we want to put all of the constants into one side and put all of the x values in another side, right? XY values in the other side and then the constants in the right. Yeah, it's a bit difficult if most of them are letters, which is kind of funny. So the way we're going to do this is we're gonna label all of our constants and then the ones that we need to put in the other side. Okay, so these are our constants, right? Those are constants, and we definitely have to put them in the right side. What else? There's a constant. Our multipliers are constants. And these are our, at least the ones we need to put in the other side. Yeah, so we're gonna have to put this one, and this one. Okay, so how is that gonna work? Well, so from here we basically have x squared. So we copy everything that we haven't boxed. 2x xp plus y squared 2y yp plus z squared 2z zp. And then here we subtract these. So this is going to be minus alpha squared x squared plus 2x alpha squared z x cubed. Right? Then we also subtract the y. That was our z. And the z. Right? This is a 2, by the way. So confusing. So that's 2. Okay. So we have that. And now we want to equate that to all of our constants here. So we basically have alpha squared x q squared plus alpha squared y q squared alpha squared z q squared minus xp squared yp squared zp squared. Right, so this is just us arranging. So here we managed to put all of the x's in one side, all of the y's in one side, all the x, y, z's in the left side, and then all of the constants in the other side. So that's what we just did here. Right? And then now from here, we want to rewrite them in such a way that we can complete the square in our next solution. So how do we want to rewrite this thing? Well, we have this x squared, so we want to combine these terms. We have our 2x here. So you want to combine these terms. And it's the same for our y and our z. So this first term, right? So we have x squared minus 2x xp. So basically whatever this is, we're gonna we're gonna make use of that. We're gonna do the same thing for y and z. Then we have this thing here, right? And then funny enough, we can combine these things. We add this thing. Then from here, we can pretty much factor out the x squared. So this is 1 minus alpha squared, x squared. Here we can factor out the 2x. And so this is alpha squared x cubed minus xp. Right? Amazing. So we managed to do that. So knowing that we did that, we just put this here, we plop this there, and we change everything to y. So this is y squared, 2y, y, y. We add that. Why am I saying y? Yeah, we basically add those, right? Then we have this other one. This one's a z. All right, we add them. Yeah, we add them, yeah. Yeah, I think, wait, let me re-look. Hopefully I didn't get it wrong this time. Oh, I can't look back, lol. Anyway, yeah, this should be, I should add them, right? And we add this thing, yeah. So it should be the same. Then when I move to y, it's just adding them. So, okay, to z, I'm gonna put y again. There we go. Now we have that. And we equate it to this thing here. So we just copy paste. Okay, so yeah, so I've just compressed these. Yeah, now this is in the all of these are in the form of this one. We don't really have a C, but here are A, let's say in the X, but I think it's the same for all of them, pretty much. This is 1 minus alpha. Then our B is 2 times alpha. Could be, I'm just gonna do X, but could be Y as well and Z. But, and then that's our B, right? Okay, so what are we gonna do now? Well, we're now gonna complete the square. So I'm gonna put complete the square. And we can use that formula that we used earlier. So it was ax plus b over 2a squared minus b squared for a plus c. This formula. Okay, so the way we're going to use this is we're going to try it on one of them, and then eventually it will work for all of them. So how do we do this? Well, let's say we have this thing right here, x squared. We add it to 2x. I think it was like that. Yeah. Minus xp. And here we can equate this to, so this is 1 minus alpha squared. This is x. We add it to RB. That's RB. We divide it by 2 of this. We square that thing. We subtract. So we do this thing again. We square that. We square B. And then 4 of this. Right? And here we can cancel this thing. Another thing we can cancel is basically what's going to happen here. There's going to be a 4. There's going to be squared. And we can cancel the 4 here. And we basically get this. Right? And so from here, we just copy it. We do it for X, Y, and Z. Another thing we can do is this thing right here, or B, kind of, because we already put out the 2, is we can factor out a negative. So that's going to be X minus, like the one in the formula. And if we do that, this is now going to be positive, this is now going to be negative. So basically it's minus. And then we just switch these around. And we have that formula right there. Right? So if we want to do it for all of them, well, we have this. So we did it here. I'm gonna delete this thing. Actually, that way we just do this. Yeah, so we have that, and then we add it to each of them. So we add, and then, oh, then we copy this, paste it again. Yeah, because we're doing it for X, Y, and Z. Then here we just change all of these to Y. Oh, change all of these to Y. So Y, 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 Y. Is that it? Yeah, that's it. And here we change this to Z. Oops. To Z. So this is now Z, 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 Z. Okay. And then we will now equate this to, well, this thing right here. So we're just gonna copy paste this, which is basically some number, because those are all constants. Right? Okay. Then, oopsies. Uh-oh. Nothing's working again. Anyway, we're gonna push through it. One note's not working properly. Okay, so now we have this, and we wanna, what do you wanna do? This would have been easier, but oh crap, now it's not working again. Okay, I'm going to restart my OneNote real quick. Oh, I can't minimize the zoom. Okay. So I'm gonna restart my OneNote. I'll share my screen again. And voila. Okay. We got it working again. Nice. Okay. So here we basically want to get all of these guys here to the other side, to the right-hand side of the equation. So how do we do that? Well, my favorite thing to do is copy paste. So that's what I'm gonna do. So I'm gonna copy paste this thing. And right here, right? So we have that same thing. We equate it to this thing. Right? And then we add these guys here. So we add them right about there. Yeah, so I'm gonna add this thing, add this thing, add this thing. Now let's see if I can make it nice. Oh, well that, it's not so bad. Yeah, so it's, can I can minimize. There we go. So I'm adding these and I'm equating it to this thing. So now this is an equation of a sphere, right? This is basically just some number, right? Because we don't have any x's and y's anymore. xq, xp, yq, yp, zq, zp. Those are all just constants. The alpha is some multiplier that we have that's given to us at the beginning, which is also a constant. Now, what's left to do here is to factor these. 1 minus alpha squared, right? So this 1 minus alpha squared, I'm just going to divide it to the other side. So actually, can we do this? Maybe, I'm not sure. We're gonna try. We're gonna try making it look nice. Okay, we add a plus there, we add a plus there. Oh, there's already another plus here. Okay. And we're equating it to this thing right here. But this thing, we're dividing everything by 1 minus alpha squared, right? So how do we do that? Well, yeah, we just divide everything by it. So it's this whole thing. Can I? I'll do this. And this is 1 minus alpha squared. I can make this cleaner, but yeah, this is our equation of the sphere. So from there, we can now find our center. So our center is, assuming I did the math correctly, our center is this thing right here. So our center is xp minus, I think it was alpha, I didn't memorize it, alpha squared x q over 1 minus alpha squared. Now we just do it for y and z. Y, q, and z. So that's our center. You know, we can test it out to see if it works. Well, we're gonna plug in the values that we got earlier from here, right? So to test this out, let's see if it actually works. Yeah. So our P was, I'm gonna erase this. Our P was this, our Q was this. Let's test it out, see if it works, yeah? So I'm going to put this here, copy paste it. Let's try and see if our formula works. So we have PQ, we have some R. Actually, we don't even need the R. Look, there's no R's here. No X, Y, Z's. We just need our XP, YP, and ZP. XQ, YQ, and ZQ. And our alpha was 2. It's also one thing. And yeah, that's all the information we have. So let's look at it. So our X value is going to be XP. So -2 minus alpha squared. So alpha squared. So 4xq times 6. We divide it by 1 minus alpha squared, so 4. That's our x value. So it's -2 minus 24. 1 minus 4, -3. And we have -26, -326 over 3. Can we check? It should be 26 over 3. And it is. See that? So we managed to get it, right? Look, it's this 26 over 3 here. And let's try our y. So we got our x, which is really nice. Very, very nice. Let's try our y here. So we plug in the 3. I'm kidding. YP, right? It's so nice though. You can make this. Alpha squared, so that's 4. YQ, so that's 3. 1 minus 4. So we have 5 minus 12. -3. 5 minus 12 is -7, I believe. And then it's just 7/3, which is, so this is our y, 7/3. And we also got it here. Right there, 7/3. And lastly, let's try our z. Yeah, I'm just making sure it works. So for our z, we have zp, so 2 minus alpha squared, so that's 4. We multiply zq, so that's -1. And then we have 1 minus 4 here, so that's 2 minus, no, 2 plus 4, -3. So that's 7. Kidding, not 7. That's 6 over -3, that's -2. So our z is supposed to be -2, which we also got here. Right? Okay. So we can now say that this works. So that's our center, right? I'm going to erase this. So now we have a formula for our center in terms of alpha or xp to zp or xq to zq. And now we want to find our radius. Our radius is basically just, well, this whole thing. I know it's complicated, but it's this whole thing. And then we take the square root of it. And that's our radius. So now, how can I simplify? That's the issue. My idea here is I can factor out, actually, let's simplify this, yeah? So we can factor out this, so you have 1 minus 1 over 1 minus alpha squared. We can factor out the alpha squared here. And here we have xq squared plus, oops, yq squared plus zq squared. And then we subtract xp squared plus yp squared plus zp squared. And then we add it to this thing. Actually, we can combine this thing, which is funny. Yeah, so we combine it to basically, oops. Yeah, this is too complicated even for me to simplify. Unless you guys can simplify it, but yeah. And then this is alpha xq minus xp squared. So I'm adding it to this thing plus my y plus my z. Wait, I keep saying q here. That's funny. This is b. And then that's everything that's just divided by 1 minus alpha squared. And so that's the whole formula there. Can we make it cleaner? No, we can't. Yeah. So our radius is basically, this thing square root, which is r, right? Or actually, it's plus minus. Yeah, because it depends if pretty sure it depends on r itself. Yeah, it should. Yeah. But yeah, it's either a plus or a minus square root. It depends on the values that are given. But yeah, that's for r. So let's test it out. I really don't want to test this. Anyway, let's see. So we get our points here, and let's see if we get the exact radius. So we should get, let's copy paste this here. Let's try and see if it works. Because we know we have a functioning center formula, but we don't have a, uh-oh, OneNote's not working again. Oh, there you go. Then watch, it's not gonna work again. Okay, I will restart this thing. Yeah. I'll restart, open it again. Okay, now I can share. There we go. So to test this out, we're gonna try our old points, right? Whoa, why is that so big? No idea why that's so big. Now it's too small. Okay, we're gonna try these points here. Oh, I took a picture. Oh my god. Anyway, so that was a picture. Now I can't erase it or anything. Yeah, so this is our oopsies. So this is our XP, YP, ZP, XQ, YQ, ZQ. Oops, ZQ. Okay. So now, yeah, we can try this stuff out. Also, we have our alpha to be 2, right? Let's see. So we're doing the square root of 1 over 1 minus alpha squared. So 1 over 1 minus 4. So that's 1 over negative 3. So that's negative 1/3. And then we're doing alpha squared. So that's 4 times our q here. So 6 squared, 3 squared, negative 1 squared. So that's 6 squared, 36. Y squared, so that's 9. Please don't tell me I said 6. 3 times 3 is 9, because YQ squared. Negative 1 squared is just 1. And we can clean that up immediately, because I don't want to do too much here. That's 46, right? 46 times 4, that's 184. So this whole thing is 184. And then we subtract it to xp squared, yp squared, zp squared. So we subtracted the negative 2 squared, so that's 4. We add it to yp squared, so that's 5 times 5, 25, plus 4. So that's 25 plus 8, so that's 33. That whole thing is 33. And we get 184 minus 33 is 151. Yeah, I'm trying to make it as clean as possible. And now we go to this part here, the long one. Now we add it to everything. Let's see. So we have alpha squared, so we have 4 xq. So 4 times 6 minus xp. So minus negative 2. So it's plus 2. And we square that thing. Plus, yeah, here I'm gonna do the whole thing. Then we go for the yq. So 4, 3 plus, it's not plus, minus y, oops, I forgot the p. Yp. So minus yp. Yp is 5, so this is minus 5. We square that thing, and then we'll go for this last one. So 4, again, 4 times zq, negative 1. And then we subtract it to zp. So zp is 2, so minus 2. We square that thing. All over 1 minus alpha squared. Oops. All over 1 minus 4. Now, what does this look like? We'll see. So this is 24 plus 2, 26 squared, 26 squared is 676. So this is 676. This is 4 times 3, 12, minus 5, 7. 7 squared is 49. So plus 49. And then negative 4 minus 2 is negative 6 squared. Negative 6 squared is 36. And then 1 minus 4 is negative 3. Cleaner, right? And then 676 plus 49 plus 36 is 761. Can we divide this by 3? Nope, I don't think so. This is a negative, so we subtract 151. Maybe we can get their common denominator here. So this is 453 over 3. And we get a negative value, which is perfectly fine because this will give us a positive value. So this is 308. So this is negative 308 over 3. Yeah, so here I'm just putting the pieces. And this is positive 308 over 9, which is exactly what we got earlier. Right there. So yeah, a bit tedious on my end, but hey, it works. We created our own formula that somehow works. Yeah, so I managed to get an R here. So I'll just zoom out so that you guys can see. But based on that problem, we managed to make our own formula that will give us a center and a radius. So yeah, that's all for today's video, and I'll see you guys in the next one.